So let's see what we can do here with this one. Also, we've got some more, we've got a rational function, has some trig functions in it. So what I want to do is, in this case, you have a few more, possibilities, right? So we can try, like we did in the previous one, just letting the whole denominator be u. All right, du then is 2 cosine x, derivative side is negative, right? Whoops, du dx. All right, well, this is not going to help me, is it? Right? This is just crap, because I don't have any of this. So this is not a good choice of u. So this is the sort of thing that will happen sometimes when you try something, it doesn't work. Well, the next thing to do is try something else. Notice if I just made cosine of xu, then I have my sine x dx like I need, right? So let's try that. Then du dx is minus sine x. So minus du is sine x dx, right? Because this top part is sine x dx. So if I want, again, I can rewrite it. Like this. And then when I make my substitution, I have this. All right, well, what is that? That actually is a thing that you should recognize. This is inverse tan. Okay? So even though when I made the substitution, it didn't necessarily look super easy, if you go back to your sheet, and in fact you should know all these, but I know it at first, okay, go back, look at the sheet, whatever. You'll see this form, okay? And that form is inverse tan of u, so I have minus inverse tan of u. That's my answer there. So then when I put in, what was u? Cosine? So I have minus inverse tan of cosine of x. And that's my answer. Okay? So if it turns out that your first choice of your u doesn't help you, like you can't plug it in and make something decent, then another thing you're going to do is go try and make a different choice. Yeah. What you want to be able to do when you do these u substitutions is you want to make all of the x's turn into u. Okay? So if I made some of them turn into u and still have some x's left over, that's no good. The whole thing has to be changed to the new variable. So if I can't figure that out with the substitution that I first pick, I gotta try another one. So what I'm going to do, just to show you something, is I'm going to look at a very similar problem, but I'm going to change slightly. Okay. Now instead of being sine of x, the top is sine of 2x. So a very small change, I just threw a 2 in there, right? But in fact, we'll see the whole thing comes out completely different. The first thing is, I'm faced with this problem. I look at this and I'm like, you know what, this is bad. Well, it's not bad, but it's not good, right? It's not that easy. I have to do something else because I've got x and I've got 2x. So I could change 2x to, I could let u equal 2x. That's not going to do me any good here. It's not going to do me any good there. I've still got sines and cosines. So one thing, whenever you have different arguments, that's never good. Like you all want them all to be the same. So the first thing I'm going to do, if I see a problem like this, is there some kind of trig identity that helps me make all the arguments the same? With 2x, you know there is, right? Double angle identity, you know that sine of 2x is 2 sine x cosine x cosine squared x dx. Okay, now because I just did the other problem and it was like this, you can probably see what you're going to have to do here. But if we hadn't done the previous problem, you might spend quite a bit of time figuring out, all right, what the heck am I supposed to do here, right? That's just one of these things where it's about trial and error. But since we saw it in the other case, now you remember, perhaps, 5 minutes ago we did this, and the derivative of cosine squared is 2 cosine sine, right? Chain rule it, right? 2 cosine x, the derivative of cosine is negative sine, so I lied, I forgot a minus. These things happen. So, minus du is 2 cosine x sine x dx, and that's exactly what we have in the top, right? The cosine and sine are mixed because that's just how I remember my identity, but fine. So when I put this all in, this integral ends up being minus du over u. So this awful thing turns out to be something very nice. So now I go ahead, this is minus natural log of u. And what did we say u was? U was this whole crap. So minus natural log of 1 plus cosine squared x plus c. Is there any other way to do? Possibly. Like when you've got trig functions, there's other stuff you could do. I could change cosine squared x to something with cosine 2x, something, whatever. I don't remember those though, so I'm not going to do it. But yeah, there are other ways of doing it. You could have kept it all 2x somehow or whatever. Do be careful though. It's tempting to say, oh, 1 plus cosine squared x, that's sine squared. It's not, because it's a plus here, not a minus, okay? So be very careful when using your trig identities that you're using them properly.